Hello everyone, I am Niranjan Kane, studying in Sri Venkateswara College of Engineering. On behalf of my assignment, I am here to explain the topic called stack class implementation on the subject named Oops with Java. So let's jump into the topic. Stack class implementation in Java, which can be studied also in data structure, operating, and more subjects. Introduction to stack class implementation in Java. The stack class in Java represents last in first out data structure, which means the last element which has been entered into the stack will be the first element to be removed from the stack. It extends the vector class with 5 methods that allow a vector to be treated as a stack. Stack class in Java is a part of Java collection framework. Creating a stack object in Java. To create a stack object in Java, import the java.util.stack package and initiate the stack objects using the stack constructor, which is given below. Stack in the open bracket string and stack is equals to new stack open and close parenthesis creates an empty stack of strings. So as you can see in the image, there is an example to how to create an stack in Java. Pushing elements into the stack. Use the push open parenthesis element and close parenthesis method to add elements to the top of the stack. So we can write it as stack dot push open parenthesis in double inverted comma like Java and close the parenthesis with the semicolon adds the Java to the top of the stack. Elements are added and removed from the stack in LIFO manner. Popping elements from the stack. The pop method removes and returns the top element from the stack. So we can use stack.pop open parenthesis and close parenthesis with semicolon removes the and returns the element from the stack. It is important to check if the stack is empty before popping elements to avoid empty stack exception. So we can see in the image as the first element is empty stack which is named as top is equals to -1. If an element is pushed into it and the top will be 0 and the stack 0 will be number 1. If the second element is pushed into the stack, then the top element will be 1 and the stack element will be 2. If again the third element is pushed into the stack, then the top element will be 2 and the stack element will be 3. To pop the element in the FIFO manner, so the top element will be removed, which is named as third element, and return to the stack of second element. Peeking at the top element of stack. The peek parenthesis method returns the top stack without removing it. String top element is equals to stack dot peek parenthesis and semicolon retrieves the top element without removing it. Peeking allows you to view the top element without altering the stack. In this method, we can just view which element is placed on the top of the stack, which is neither disturbed nor edited. The next method is checking if the stack is empty. Use the empty method to check if the stack is empty. So the code which has been used is if in open parenthesis stack dot empty open parenthesis and closed parenthesis. In the floor bracket, we print the statement using system.out.println. Stack is empty. So we end that statement by putting a semicolon next to it, which is used to check the stack is empty. Empty method returns true if the stack is empty, otherwise it returns as false statement. Searching for an element in the stack. The search element method search for an element in the stack. So the code which is used is int position is equals to stack dot search. The parenthesis with the double inverted comma we write as Java. So the Java element which has been implemented in the stack will be searched and viewed to the user. The method returns the one based position of the element from the top of the stack. Size of the stack. The size method returns the number of elements in the stack. So the code which is used to identify the size of the track is int stack size is equals to stack size stack dot size in the parenthesis, which is used to retrieve the current size of the stack. The size method is useful for checking the number of elements in the stack. So we can identify the total number of size present in the stack using size of the stack method. Iterating through the stack. Use an iterator or a for each loop to iterate through the elements in the stack. So the code is iterate string iterate is equals to stack dot iterate creates an iterator for the stack. So we can also write it as for in the parenthesis string element equals to stack and the printout statement is system dot out dot println the parenthesis right element. So it iterates through the stack elements. So the final conclusion is the stack class in Java provides a simple and efficient way to implement a stack data structure. It offers methods for pushing, popping, picking, searching, and checking size, and even iterating through elements. Understanding the stack class implementation is very essential for working with LIFO data structures in Java. So that's all for today, guys. Thank you so much.